So we need to figure out what a is. Okay, well, let's do that. So to get a, okay, to get a, we know that is it's given. The graph passes through the point 17. So since it passes through the point 17, this is telling us that 1 gets mapped to 7 under our function f. In other words, f of 1 has to be 7. That's what this is saying. So f of 1 must equal 7. That's all I'm trying to say from this. As we can see. So since f of 1 has to be 7, when x is 1, we must get 7. So from there, we get this equation. F of 1 is 7, and we're replacing x by 1. So from here, we get 7 is a times 1 minus 4 squared minus 2. And now we just simplify a bit, because we know 1 minus 4 is minus 3. So we get a times minus 3 squared minus 2. Minus 3 squared is 9, so we have this. Again, I put a, the unknown, to the right of the number like this. I mean, if you left it as a times 9, that's fine. So we get 7 is 9 times a minus 2. Now, you might be able to see right away what a is, visually, but if you can't, that's okay. I like to err on the side of caution because I don't know everyone's background here. So let's solve for a. And that's what I'm doing here. Again, I did email you guys the notes. I mean, the pen stuff isn't in it, but you still have it in front of you. So we get 7 is 9 times a minus 2. Right, so we want to solve for a. So I wrote this as 9 times a minus 2. 9 times a minus 2 equals 7. From here, we're going to add 2 to each side. And so we get 9 times a equals 9. Thus, we get 9 times a equals 9. So we divide both sides by 9, get a equals 9 over 9, which is 1. So a in this case is just 1. And this is our quadratic function. All right, that's good. Okay, so that's it for this section. Are there any questions on this? Because now I figured it'd be good to start the next one. Let's do that. Okay, let me get to the notes. Hold on, it's just saving, so there we go. All right, let me just share those. Here we go. All right, there it is. This I emailed to you guys, so you have it. It's in your inbox. So here, what we're going to look at is the division algorithm for polynomials. So just like we can divide one integer by a non-zero one, and we get a lot of nice results, and we use division for instance, when factoring integers. Same thing for polynomials. In other words, if you have a polynomial f of x, capital F, okay? And let's say you decide to divide it by a non-zero polynomial p of x. What's going to happen is there's going to be two. Then what's going to happen is you're going to have a quotient q of x and a remainder r of x. when you divide. From dividing, what you actually get is this. This is the same thing for integers. I'm not sure if you've seen it like this, but it turns out you can do this for integers as well. Now, this is useful, but it's really better, I think, to write it this way. It's more useful. So if you divide f of x, a polynomial, by d of x, a non-zero polynomial, you get a quotient q of x and a remainder r of x, where the remainder, though, is either 0, which can occur with integers, or its degree is less than the degree of d of x. You know how when you divide integers, there's some kind of condition. If the remainder is, I think, an absolute value less than something, and you can stop. It's the same idea here, except we're not using absolute value. Looking at degree. So that's what's happening here. And so capital F of x, this is just some terminology. That's the dividend. Q of x is the quotient. E of x, what you're dividing into F, is divisor. R is the remainder. Now, this is more complicated, though, than for integers, as you could probably guess. It is based on degree. Okay, so again, the remainder, right, is either the 0 polynomial, which basically means it's 0 always, or its degree is less than the degree of d of x. So this is basically based on degree. I think they go more into that in the textbook. What I'm going to focus on, though, is this case, when d of x is of this form, x minus a, where a is just a number. In that case, it gets a little bit easier. I mean, the degree of d of x is 1. So it is a little bit easier. And we actually have what's called synthetic division. So we have d of x is x minus a, where a is a constant. A is a number. And really, to illustrate synthetic division, what I'm going to do is write out the procedure, but with each step, I'm going to illustrate. In other words, I'm going to do this along with an example. So here's what we do. So again, we're assuming that we're dividing capital F of x, right, by a polynomial of degree 1 of the form x minus a. In this case, we're dividing this polynomial by x minus 3. Okay. So I know I put it over here, but not over here, but this is our f of x. Now what you want to do first is you want to fill in the missing terms using 0 as a placeholder. In other words, this is degree 4, but notice there's no degree 3 term here, right? That's missing. We're going to use 0 as a placeholder for it. It's kind of like what we did when we added and subtracted polynomials vertically, right? We put 0 in as a placeholder. Same idea. So how do I say this? So for every missing term whose power of x is less than the degree, you want to use 0 as a placeholder, as you can see here. That's what I'm trying to say. I mean, it's written out here, so here it's written fine, I guess. So you're using 0 as a placeholder for every missing power of x less than the degree. Now, what we're going to do is we're going to make this table here. As you can see, I'm listing the coefficients here in this table. Notice I'm including the minus signs with the coefficients and the zeros here as well. I don't put minus 3, though. I put 3 here in the first column. The first column is if you have x minus a, or in this case 3, we're going to have 3. And then you're listing the coefficients of the dividend, as you can see. So this is the same as before. What you do next is this. You're going to bring this in the second column, which is the first coefficient of capital F of x. You bring that down, as you can see. Then you're going to multiply your a in this case, which is 3, by the coefficient. So we have 3 times 2, which is 6. That product is going to be in here. It's going to be put here. 1 column to the right, 1 row up. So one column to the right, 1 row up. Basically, what I'm trying to show you here is multiply whatever that product is, you put up here. So let me say it again. I think I might have accidentally skipped something, but I forgot to say it. I mean, the 2, the first coefficient you bring down, right? That's what I have here. Multiply the a, which is 3 in this case, by that coefficient. That product you put over here, 1 column to the right, 1 row up. Then we're going to add 0 and 6, for instance. We add, that sum goes here. So 0 and 6, we add, that goes down here. Okay, now what? Well, the process will repeat. Basically, what we did to the 2, we're going to do to the 6. So next, what we're going to have is 3 times 6, which is 18. And that's going to go here, as you can see. 3 times 6, which is 18. That's going to go here. Then you're going to add, right? Just like we added 6 and 0, we're going to add 18 and minus 3, which is 15. And that's going to go here. Again, you multiply, put up here, add the. So again, we have 3 here, right? We multiplied it, we brought the 2 down. 3 times 2, 6. That product goes here. 1 column to the right, 1 row up. We add, sum goes here. And we repeat. 3 times 6, which is 18. That product goes here. You add, and you get 15. And now the 15, right, we do the same thing. We have 3 times 15. That product is what? 45. That goes up here. We have 45 here. And now, okay, that sum, which is 50, that goes down here. I did write down for the last one here, you want to separate it by a vertical line. I mean, that part is really, I guess optional, so to say, because you'll see what's going to happen now. But we repeat this process. 3 times 50, right, is 150. That product goes here. And then we add 150 and minus 63. And that gives us this. So let me say it again. We have 3 times 15, right? That's 45. 45 goes here. 1 column to the right, 1 row up. We add, we get 50. Then we do the same thing. You keep on doing this until you run out of columns, basically. You know, this is the last column, so you're not going to do the process after this. We have 3 times 50, which is 150. 150 goes here. And then we're going to add 150 and minus 63. And that gives us 87. 87.